Hi everybody, I wanted to go over some tips for graphing quadratic functions. It's all about the pattern, and I hope that as we learn other new functions, you get in the habit of knowing the pattern of the base functions and then applying that to their transformations. So let me show you what I mean by that. So for y equals x squared, we know that when we plug in 0, we get 0. And when you square 1, you get 1. When you square 2, you get 4. And when you square 3, you get 9. Because y equals x squared is even, that means it's symmetric across the y-axis. So we'll have negative 1, 1, negative 2, 4, and the point negative 3, 9. And so here is our parabola. Okay, so what I want to point out in terms of the pattern is there's another type of one, and maybe you can come up with your own, but I'm just going to share the one that I like. I think about the vertex as like the home base. And so once we know where that vertex is, we just need to know the transformations to know how to get to other points. But we still need to know how this plays first. And so what I say is, okay, if my home is at the origin, I know with x squared, if I go to the right one, I'm going up. If I go back home, I go to the right 2, I'm going up 4. If I go back home, I'm going to go to the right 3, and then I go up 9. And so it's the end. The reason why I know that is that, okay, when I square 1, I get 1. When I square 2, I get 4. When I square 3, I get 9. And then just use the symmetry. And so what's happening is, if we have a function like y equals 1/2 x squared, I'm not like, I'm playing the game, right? I'm using that fact that, okay, I'm manipulating this, but now I need to adjust it with that 1/2. And so I still know my vertex is at the origin. And if I go right 1, I usually go up 1. But now, after I go up 1, I have to multiply it by 1/2. So that really means I'm only going up 1/2. And when I go to the right 2, I would go up 4, but now I need to multiply that by 1/2, so I only go up 2. And at this point, I'm not going to even want to play with 3, because then it's going to be 9/2. But if I were to go over 4, 4 squared is 16, and then 16 times 1/2 is going to be 8. So I liked that point more. So let's go over 4, 1, 2, 3, 4, and then up 8. And then just use your symmetry. And then we can draw the curve. Kind of, sort of. So for instance, let me go ahead and erase this. Let's say I was right here, and then I had this point right here, and then this point right here, and that's all that is given. Or yeah, let's just say that's all that's given. So I can tell just from what's given that the parabola is doing something like this. It's not quite V-shaped, it's a little U-y. So that's going to be my graph, but what would this function look like? Well, I'm thinking about it in this y equals a times x minus h squared plus k form. And it looks like it's been shifted to the right, 1, 2, 3, 4. So then that means it's x minus 4 squared. And then down, 1, 2, 3. So that's minus 3 here. It looks like there is a vertical stretch, and the stretch is going, and so this is where I'm thinking, okay, if I go to the right one, it's gone up, and also the graph is being pulled, it's gotten skinnier, so it's a vertical stretch. So then I can say it's gotten up 1, 2, 3, 4. So I'm saying that my A is 4. So here my curve is my function is going to be y equals 4 times x minus 4 squared minus 3. So not only am I looking at the fact that the curve is skinny, which is telling me this has to be a number greater than 1, that I just needed to play where was my vertex, so the HK, your vertex, and then from there you're just home free. So hopefully this video helps you do the Desmos activity with a little bit more ease and enjoyment, and helps reinforce what you've been doing in chapter 1 and learning in chapter 2. All right, bye everybody.